All right, looks like we're finally live. Hello everyone, and welcome to another session. How about that? I bet you didn't expect that shit to happen. Hello, welcome. Let's make a little bit of an announcement on our Discord server. Let me find my Discord. Here it is, and I'm gonna do an announcement. A red circle. Live on Twitch. We are actually live. How about that? And what we're doing today we're doing the third day of Advent of Code in the God's Temple. That's what we're doing today. So we're attempting a TempleOS challenge where I'm going to try to solve all of the Advent of Code 2021 problems in TempleOS. I'm not sure if I'll be able to do that, but I'm going to give my honest attempt, right? So if the problems will become too hard, I'm going to give my honest attempt at solving them, and maybe if I don't succeed, maybe I'm going to just look up like a little bit of hint, just, well, nobody sees that, and edit that out of the video so nobody actually noticed that. We'll see about that. Right, so I'm actually not a god coder, so sometimes if the problem is too difficult, I cannot solve that, so it is what it is, and it isn't what it isn't. We'll see how far I can go. So, and I'm gonna need to provide the link to the Twitch, twitch.tv/Zoding, and I'm gonna ping everyone who's interested in being pinged, and boom. So the stream has officially started. You can find the source code to the solutions. Of the solutions on the GitLab. So here's the link. I'm gonna give it to the chat, and also if you're watching on YouTube, you can find the source code in here. Right, so and for the playlist of all of the previous recordings of the Advent of Code sessions, you can follow this playlist. I'm gonna copy paste it for the chat as well. Right, there we go. So this is basically the playlist. And if you never heard about Advent of Code, check out adventofcode.com. So it's an annual event where you have to solve 25 problems in 25 days. And if you never heard about TempleOS, check out this thing. It's a very interesting operating system with a very interesting lore behind it. So let's go. So I'm gonna actually go into my TempleOS development environment. By the way, hello everyone, welcome. Chair Gaming GNC, Nerdy Pop Rocks, Copper Casted, I Good Duke, Rebel Wilder, Iritra, hello everyone, welcome. I'm sorry if I missed anyone. Right, so let me go to AoC 2021, and I wonder if I need to fetch any changes, because I might have actually done something off screen, but I don't remember that. I never remember that. Cheers, by the way. So it looks like we don't have anything, and let me actually start TempleOS. So I need to provide the password because it wants to unmount something. And let's load driver C, drive C, and let's take a look. So here's Advent of Code. You know what, I'm gonna actually extend this entire thing, and I'm gonna get rid of the autocomplete. I finally learned how to bring in and out the autocomplete window. It's Alt-A. Not Alt-W, like chat suggested, but Alt-A. And to actually close it, it's Alt-Shift-A. Right, as you can see, you can actually see the keys I press somewhere here at the top right corner, so you can actually clearly see that. And it's actually very convenient, so I can actually remove it and it doesn't distract anyone. So now I can click here, and I suppose the thing we want to do, we want to create a new folder for the third day. So it's going to be dear MK 03, and there we go, we have a third day. So I'm also gonna cd to the third day, and so far we don't really have anything in that folder, so maybe we want to go ahead and create main sort of like solution. Right, so, and usually one of the things I do, I like to cd to the current folder, because for some reason the current working folder when I run this entire thing is home, which is not correct. I want the working directory be the directory of the solution, so I'll have to do something like c / home AoC 2021 03. Right, so there we go. So, and just in case, I'm going to create the entry point for the part 1. Usually there's two parts in this solution, and I'm going to right away just call part 1. So let's see if everything compiles. Everything compiles, as you can see. Hello everyone, welcome. Really glad to see you all today. Okay, how are you guys doing? Are you guys ready for an epic Advent of Code time? Any advent of coders in the chat? Yes, Pog. Okay, so let's go. Ooh. So advent of code. So the third day. Binary diagnostic. Very interesting. The code therapy. I almost wrote it incorrectly. The code therapy. Thank you so much for Twitch Prime subscription. Your first subscription, by the way, and welcome to our epic TempleOS club. That's right. Okay, day 3, binary diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input, consists of a list of binary numbers, which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Okay, so each bit in the gamma rate can be determined by the most common bit in the corresponding positions of all of the numbers in a diagnostic report. For example, given the following diagnostic report, considering only the first bit of each number, there are 5 0 bits and 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. The most common second bit of the numbers in the diagnostic report is 0, so the second bit of the gamma rate is 0. Oh, okay. Interesting. The most common value of the third, fourth, and fifth bits are 1. Okay, so each row gives you actually 2 bits of the gamma rate, if I understand correctly. Most common bit in the corresponding of all numbers in the diagnostic report. Is the most common second bit of the number in the diagnostic report is 0. Okay. So the gamma rate. Well, no, wait. Oh. Okay, so I just read it incorrectly, so yeah, so according to how I read it should be actually double of that, but it's not double of that, so everything's fine. So 22 in decimal. The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit from each position is used. So the epsilon rate is 0.1001, or 9 in decimal. Multiplying the gamma rate 22 by epsilon rate 9 produces the power consumption 98. Use the binary numbers in your diagnostic report to calculate the gamma rate and epsilon rate, then multiply them together. What is your power consumption of the submarine? Please be sure to represent your answer in decimal, not binary. Okay, so that's actually pretty cool, and this is actually pretty straightforward. So let's actually bring the sample data into the Temple, right? So because I want to play with this specific sample data, I think it's going to be very useful. Fuzzy, I hope I'm pronouncing that correctly. Fuzzy X86, thank you so much for Twitch Prime subscription. Thank you, and welcome to our epic TempleOS club. All right, so let me go and mount the TempleOS image. There we go, and I'm gonna go into MNT home AoC 03. Right, so let me create sample txt, and I'm gonna just copy paste this sample input. Maybe I might as well actually bring in the the actual input as well, right? So I think it's going to be also very convenient. So let's get our puzzle input. Harrison, thank you so much for 2 months of Twitch Prime subscription. Thank you, thank you, thank you, and welcome. It's not Twitch Prime, tier 1 subscription. And welcome to our epic Advent of Code Club. Okay, there's a lot of shit in here. So these things are obviously bigger. So how many bits do we have in here? So here is 8 and 12. There is 12 bits in here, which is actually rather interesting. Okay, so let me copy paste this entire thing, and I'm gonna start the insertion mode, insert everything in here, right, and then save everything. There we go. So we have exactly 13,000 bytes in here, which is rather interesting. So exactly, that's very interesting. So yeah. Anyway, so let me now go back and let's start the virtual machine. So this is going to be drive 1. Let's not take the tour, and I'm gonna remove that, and I'm gonna actually extend the window slightly in here. Okay, so I'm gonna go in here and then O3, and here are the inputs that we've got. So here is the sample input, and here is the actual input that I have to parse. So I have everything in here. So main.hc. So in here, the first thing we're gonna do, we're gonna read the whole file. Vinipimba. I hope I pronounced your nickname correctly. It is definitely not a drill. It is TempleOS. Thank you so much for 2 months of tier 1 subscription. Thank you, thank you, thank you, and welcome to our epic temple, the God's temple, not just epic temple, epic God temple. Let's go. So we need to do something like file read, I suppose, right? So and then. File read, if I remember correctly, we're only interested in 2 parameters in the file read. It's the file path, right? So this is going to be sample txt, and the size. There we go. So i64 size, and now we know essentially the beginning of the file, right? So where it begins, and the size of the file. And so the question is, what is going to be the easiest way to parse the entire thing? Is it going to be by using text, or is it going to be by using numbers? Because here is an interesting thing. We have a function called str2, let me actually bring the autocompletion, str2i64, and this thing accepts radix. That means it can also parse binary numbers. We can instruct this entire thing to parse binary numbers, so we can get a stream of binary numbers. And then using bit operations, we can just access each individual bit of this entire thing. That way, I don't have to write any additional things to parse strings and convert strings. Like essentially, we have everything already. So I might just use this function. Okay, so I'm going to give it a try. So while size is greater than 0, actually greater than 1, right? We're gonna do what? So I also need to have a separate thing that I'm gonna consume. So this is gonna be string, it's gonna start at begin, and we also need to have the end p, right? So end p is initially gonna be null, but I'm not sure if it matters. Okay, so there is such thing as null in here, which is nice. The font is really painful in here, and the most painful thing about that font is the line height. So if there was a little bit of spacing between the lines, it would have not been that unbearable, because lines actually merge together. Right, so if you take a look at this thing, so this G actually merges with U below, forming O or something. If there was like at least one single like pixel of space, it would have been more readable. Without the coloring, I wouldn't know that there is like... Yeah, so... And it's not that even difficult to fix, I think. Maybe not. Yeah, maybe it is difficult to fix because it's like the whole screen is divided into regular size characters, so maybe it is not that easy to fix given the architecture. So yeah. Yeah, like a bigger line height would be actually pretty good, I think. I think it would be actually pretty good. Useless Pony, thank you so much for 4 months. Thank you. Of course you are. Thank you. Thank you so much. Welcome to our epic TempleOS club. Alright, so let's go. We're gonna do str to i64, right? So it's gonna be I. Why don't you? So there's something. Oh, this is probably because. Okay, so my TempleOS is actually broke, and I don't know what is going on. So I have to maybe restart, and it didn't even save anything. We're off to a great start. Like it didn't. Cat fucking damn. Okay, so I have to retype all of that yet again. God damn it, thank you so much, Terry, very cool. So I64 size, right, so U8, this is begin, so this is gonna be file read, right, and in the file read, I'm gonna read the sample.txt, and we're gonna accept the size. So then I'm gonna reassign this thing in here, so this is gonna become the begin. And the only reason why I keep track of begin is because I want to free that begin, because file read yet again allocates the memory, so we want to deallocate that memory. And in here we're gonna have like a temporary variable that keeps track of the end of the parsing. While size is greater than 1, we're gonna be doing the following thing. Right, we're gonna do str to I64, we're gonna accept the string beginning, then the radix is gonna be 2 because we're parsing binary number, right? We're parsing binary number, and the pointer to the end is gonna be here. So, and in here we're gonna get the number, right? So we're gonna get the x, but we need to allocate that x somewhere. Let's actually allocate it somewhere here. Okay, so after that, what I need to do? I don't think I need to do anything special, so essentially I need to take end p and subtract str, and I will get the size of the number, and I need to subtract it from the size of how much we already parsed, and I'm gonna reassign the end to the end p. There we go. So that way I can just basically go through each individual number. We can actually test that. I can print the number in here. There we go. So if I try to press 5, it says something on the line 10, duplicate member at equals. Okay, so let me take a look. So it's gonna be 10. All right, I forgot. Oh, okay, so I forgot the semicolon. All right. So, and did it work? I'm not sure. I'm not sure if it actually worked. So let me do something like this and run it one more time. No, it still complains. Duplicate member. Oh yeah, I see what's going on. So it's just reflexes made me make this a declaration, because like I didn't have to do that. Okay, there we go. So here are the decimal representations of the numbers of the sample, right? So if you take a look at the sample.txt, here are basically binary, and we parsed it as you know, decimals. So we have an access to them as decimals. So since we kind of know a very important information, the information we know is that the maximum here is 12 bytes, right? 1, 2, 3. 3 by 4 is basically 12, right? So we can actually only consider first 12 bits of the parsed number, right? So we don't have to consider anything else. All right, so how can we do all of that? So maybe we need to maintain the array. Maybe we need to maintain the array of how many like zeros we have and how many ones we have and stuff like that. Let's go ahead and allocate that array. So it's going to be basically array of 12 elements, right? So maybe we can even define some sort of a magical constant called bits count, and it's going to be 12, right? So this is going to be bits count. And in here I want to do something like U8. No, it's actually going to be I64, and we're going to have something like once bits count, right? And I wonder, can I basically initialize all of that with zeros? Maybe there is something like memset, right? And I64, this is going to be zeros, right? This is going to be zeros, bits, BTS, bits count. Right, so the real question is there something like memset? So let me see, I'm gonna do memset. There is something, I think I saw it. Okay, so there's also memset I64, but I'm not sure which one do we care about. So memset accepts destination as U8 and the counts. Okay, I'm interested in memset I64. What's up with that? What's up with I64? So, and set chunk, let me remove, oh my god, I can't remove this thing. Set chunk of the value, I can't see, this is so painful. Just a second. So this is the destination. You want to set it to a specific value. And what is the count? I suppose it's the amount of I64s that you want to set. This is actually very convenient function. This is actually a very convenient function. So yeah, I really like that. Terry actually thought about everything. All right, so we're gonna use memset I64, and I suppose it accepts the destination. Destination is gonna be basically once. We're gonna set it to 0, and the amount of things we wanna set bits count. Right, there we go. As far as I know, oh shit, can I? Oh fuck! I don't know how to do Control Z, so fuck. Okay, so if I just close this entire thing. The most annoying thing about TempleOS is that it remembers the selection for whatever freaking reason. It's so annoying. Like, how do I deselect this thing now? Oh, I'm in undo mode, so I'm not sure if, like, what am I even doing? So do I do that, or do I do that? I don't even know what I do. So as far as I know, like, there's nothing you can do about that, because that selection is probably saved in the document itself, because that's what TempleOS does. It saves the position of your cursor inside of the document. It saves a lot of state inside of the document, and if you fucked up something inside of the document, opening, like closing and opening probably won't help, because it's inside of it. Right, so one of the things we can do, we can close this entire thing and just do AoC 2021. All right, so and let's actually go there, AoC 2021, and I probably, did I already mount it? I think I already did. So this is going to be home, and this is going to be 03, and if I take a look at there we go. Okay, so yeah, look at that. It inserted this thing, and I have no idea what that is. Right, it's probably something about selection. Right, and the easiest, oh wait! I remember there's a key in TempleOS to actually like go into like a raw text mode, so you can remove all of that shit. I do remember that. This is actually quite important. So let me see. So I'm gonna just close this everything in here, and I'm gonna run TempleOS one more time. There we go. So we're learning an operating system. So part of the challenge is actually, you know, learn this entire stuff, right? So eventually, by the 10th day, we're gonna be very proficient in this operating system. Trust me. Cup. All right, so if I remember correctly, the combination is Control-T. There we go, and you are able to see all of that crap that is polluting your source code. And I think you press Control-T one more time to actually go back. Okay, so this is how you do that. I'm starting to remember. All right, and on top of that, I remember there was like a cheat sheet. TempleOS editor, yeah, editor cheat sheet, which I probably should keep around just in case. Okay, so no, it's not that one, but I remember there was like actually pretty good comprehensive cheat sheet for the editor. Oh my god. Alright, doesn't matter. So Google is not being cooperative right away, so I don't really care. Anyways, so let's put it this way, and yeah. So what I want you to do, I want you to do memset on all of these things. I want you to do mem set. The destination is going to be once, 0, and then bits count. All right, and then it's going to be memset zeros. I'm going to set it to 0, bits count one more time. Okay, that's cool. Now, what I need to do, I need to basically iterate through the 12 bits of the number, right, and basically count the corresponding bits in the arrays, right? So let's do something like this. I probably need the iterator. So I'm gonna actually put it in here. So this is gonna be I, and I need to now go back to here. So I 0, I less than, let's actually keep it like that, less than bit count, plus I. Allowed Zor, thank you so much for 11 months, almost a year. Yes. Thank you so much for 12 months of Twitch Prime subscription. Thank you, and welcome to our epic TempleOS club. TempleOS. Cheers. All right, so let's go. And here is the interesting thing. So how are we actually setting all of that? Right. So if I just go ahead and do xi, right, if I do xi and then and 1, I'm actually getting the rightmost bit. So maybe we're gonna store bits in ones and zeros array in a reversed order. So first come the, you know, the rightmost bits. And we'll keep that in mind because that way I don't have to like convert anything. So, and in here, I can do the following thing. So if it's 0, I need to increment 1. If it's 1, I need to increment the other. It would be kind of nice. It would be kind of nice if I could do something like bits, and I could select basically a specific bit. So this is going to be I, and then just do something like this, and then plus plus. You know what I'm talking about? Right, so instead of having like two arrays, ones and zeros, I had one two-dimensional array with 2 rows, so I can quickly select the, you know, the bit that I want to increment in here. You know what I'm talking about? I think it's actually a pretty cool idea. Right, so let's actually refactor all of that. So I didn't even think about that until I actually implemented this thing, right? So this is one of the recurring themes in software development. It's kind of difficult to predict what you need to do and plan ahead until you start doing it. Right, at the beginning I thought it would be a cool idea to have 2 arrays, but when I actually wrote the loop, it turned out, well, it would be kind of cool to have only 1. And how could I predict that? The only way I could predict that is to actually start writing code in my head, right, see that you would need that, and then, you know, actually write it. So instead of doing all of that in your head, it's better to just, you know, do the thing and it will just emerge. Does it make any sense? I'm not sure. I think it's TempleOS starting to affect my brain slowly. Anyways, so this is going to be once, and in here we're going to have the amount of bits like 2. Right, so, and I want to just remove the line. So if I can actually remove the line. So this is going to be bits. Right, and I wonder if I can just do the following thing where I would say, okay, let's set it to bits and set it to 0, but multiply this by 2. Yeah, Yandy, I hope I'm pronouncing your nickname correctly. Thank you so much for Twitch Prime subscription. Thank you, thank you, thank you, and welcome to Epic TempleOS Club. Okay, so let's go. Uvu. All right, so we've got that. So we get each individual things in here, and now I think what we need to do. We essentially need to recover the number, right? So here we read everything, right? Here we read everything, and now we need to recover the gamma, and then we need to recover the rest of the things. So let me actually focus, because I'm kind of losing the focus. Right. So the gamma rate is the most common bit, right? The gamma rate is the most common bit. So now what I need to do, I suppose here I just need to increment all of this. Let me quickly do gamma initially 0, and the second one was epsilon. Epsilon is gonna be 0. All right, epsilon is going to be 0. And yeah, I equals 0 less than bit count plus I. And we have to keep in mind that here the first bit that we store is the rightmost bit, right? It's the rightmost bit. So, which is actually fine, I guess, because that's exactly how we're going to be recovering these numbers anyway. Right, so essentially I'm going to take bits I, and then I can do the following thing. If bits 0 is greater, if bits 0 is greater than bits bits I1, right? We're not gonna set anything, and we're gonna just keep it as 0. It's already 0 actually. So that means the only thing we care about is whether it's greater, right? Whether it's greater. And after that, if it is greater, I'm gonna do gamma, or not game, but gamma, or 1 to this, and I will have to reassign gamma back. All right, so we've got something like this. So we've got the gamma. All right, so we can probably try to recover. Oh, we can do these things simultaneously. Huh. So, it's a little bit confusing. I'm trying to be a smartass, but for some reason I don't think it works out. So that means epsilon shouldn't be modified. And in here, otherwise 1 is the smallest, and we're gonna actually assign it to the epsilon. Okay, so this is what I was trying to produce basically. Epsilon equal epsilon. It's gonna be 1i. There we go. And I suppose that's basically it, right? So, and the final result is multiply both of these things together, right? So it's gonna be part 1 d gamma multiply by epsilon. Epsilon, and that should be it. So I'm gonna actually comment out this entire thing, and I'm gonna just run it and see if it compiles. It does not compile, as you can see, and let's go to the line 22 where it doesn't compile. So it complains about this thing, and I'm not sure what exactly it is complaining about. So I64, let's actually take a look one more time. Invalid L value at bit count. Oh, it's a bits count. Okay, so I'm sorry, it's actually bits count. All right, so this is a bits count. And there we go, so everything's compiling. So we're working on the sample, right? So if I try to run it, the part 1 is... This is actually very strange, strange number, right? So, yeah. The epsilon rate, so it's supposed to be, yeah, this is definitely not correct. So maybe one of the things I want to do, I want to actually print the both gamma and epsilon, right? So it's going to be something like this, right? So it's going to be gamma, and epsilon, right? So this is going to be d. Epsilon. Okay, so what do we got? Yeah, so these are numbers, like, these are very, very big numbers. So I think I'm doing something incorrect for sure. So also there is a very interesting situation, right? So we have, what if they are equal, right? So what if they are equal? Does it even say anything about them being equal? Okay, so for these things, I guess the only time they're equal is when... Yeah, I think I made a very stupid mistake somewhere. Huh, this one is interesting. Okay, 0 is greater than 1 in this situation. 0 is greater than 1 in this situation, but 1 is equal to 0 too. So the actual condition, I think, here, for specifically for the sample, right? So I'm talking about specifically of the sample. So it's going to be that I1 is greater than 0. It is greater than 0. Otherwise, just keep it 0. So if I do something like this, and it didn't help. So yeah, maybe for the sample. specifically for the sample, I'm gonna just reduce the amount of bits, right? So let's go ahead and reduce the amount of bits. So this is gonna be 5. Was it 5? I think it was just 5. I think it was just 5, and that's already closer to what we have. So it's 22, and the last one was actually yeah, 9. But for some reason this one turned out to be 10. Epsilon turned out to be 10 for whatever reason. So let me see. So this is definitely 5, and did I? So it doesn't. It stopped working all of a sudden. I don't know what's going on. Maybe I actually studied it, but yeah. Okay, so let me run it one more time. All right. So it really doesn't care when. Okay, so it has some time. Okay. So let me. My God, Temple. It's just like I don't want to click on any of that stuff. All right, so let's go. So 03, and this is going to be main.hs. Okay, cool. So let me think. So here we're considering. The rightmost stuff. So if 0 is less, that means it's going to be this one. Otherwise, it's going to be this one. I don't see mistake in here, to be fair, but for some reason epsilon is not working correctly. Right, as you can see, it turns out to be 10, but it has to be 9, and I don't see the mistake, I don't see the error. Right, so I'm starting the bits. Right, so this is a rightmost bit, and rightmost, and I'm recovering it also in the same order. Right, I'm recovering it in the same order, so I don't see a mistake unless I misread something. It's calculating similar. Rather than use the most common bit, the least common bit from each position is used. So the epsilon rate is 0, 1, 0, 0, 1. Multiplying. Okay, I'm obviously just missing something very stupid. So I'm not sure. I just need to concentrate. So this is that. All of that is not ultimated, but 0 out. So we read this thing and iterate through this entire stuff, and then I just increment this thing, then I increment it yet again, and if 0 is, if 1 is the most common one, right, I set 1 to gamma and 0 to epsilon, because 0 is the least common one. Otherwise, right, otherwise, I can even do something like this. If, just in case, bits I 0 is greater than bits I1, right, I set epsilon to 1 and 0 to gamma, right, and 0 to gamma. And then this thing should be unreachable, theoretically. Theoretically, this entire thing should be unreachable, right, unreachable, right, and let's see if that will be ever the case, because who knows, right? So if I try to run it, I didn't see a single unreachable, and still that specific epsilon doesn't really work. What am I missing? My God, it's probably something super obvious, but yeah. It's probably something super obvious. Okay. Wait. Let me see. Do I read everything though? Do I read everything? So it could be that maybe I actually missed something. 001. Okay, so... Alright, everything seems to be okay. everything seems to be okay, but now I probably need to see how many of those I got, right? So I can try to count them, right? So I64 CNT is going to be 0, and then every time I encounter this entire thing is going to be CNT plus plus, and then it's going to be CNT D, right? CNT. Okay, so CNT is 12, right? But is that the case? Is that the case? So let me see. It is 12. Okay, so I don't see a mistake. Why is it like that? So can I STR8
holidays. Thanks for the great videos.
Thank you so much for 1000 bits. Thank you. But I need to solve this problem first, right? I really appreciate all the donations, but I need to understand what the hell is going on. Right, so I wish I could print it in binary and actually see what's going on. I wish I could do that, but I'm not sure. Oh, by the way, I probably can do something like this, right? I can probably do something like this in TempleOS, maybe. I'm not sure if it's gonna affect anything, but you know, maybe it's just like generally a good idea. Okay, so that's nice. That is very nice, very nice. So, okay, this thing is supposed to be that, right? It's supposed to be 0, 1, 0, 0, 1. We can try to basically decompose the epsilon, right? So I can just go here one more time, and for I0, I less than bits count plus I, and I'm gonna just print all of these things, right? So let's go ahead and do that. So this is gonna be D, and what I'm printing in here is essentially epsilon and 1I, right? So that's what I'm printing, and after that it maybe makes sense to actually put it like this, but it should be printed like in sort of like a reversed order, right? And what the hell is that? So it's not supposed to be actually, what the fuck am I doing? Right, this has to be I and something like this. Okay. Thank you so much for the subscription and for the donations. Thank you. I really appreciate that. Okay, 010101, which is not correct. Right, so it is definitely not correct, and I have no idea why. So maybe I have to be more explicit. Right, so gamma has to be this, and epsilon has to be 0. Like, but it's meaningless, isn't it? It's already 0 because I already set it to 0 in here, unless TempleOS didn't actually zero it out. And this is not how we set to 0, by the way. Right. This is definitely not how we set to 0. You probably want to do something like 1, right, and then you want to negate it, right? So essentially you negate it, and you probably do something like AND, right? So this is how you set it to 0, if I remember correctly, right? Because if some of these things are zeros, 1 with 0 is going to be 0, and if it's ones, it's going to stay ones. So maybe I have to do explicitly things like this, who knows? But it doesn't really make much sense unless, again, I'm missing something. Right, I could be missing something. So this is gonna be I, and let me see. It didn't work because identified undefined identifier T16. Okay, it's not a game. Okay, it's gonna be gamma. Right, so I'm gonna delete that, and yeah, it's still that. Do I have to do this stuff in a reversed order, though? Do I really have to do that in a reversed order? Like, I can try to just guess that maybe I have to do this stuff in a reversed order, but then this thing wouldn't be in a reversed order, right? So, so it's definitely not an order, right? It's something not with the order, it's something else, and it drives me nuts. Like, what the hell is going on? Am I going crazy? Am I going crazy, people? So, am I really going crazy? Because this is like, it doesn't look like. What if I go ahead and port that to C, regular C? And just see if it will solve, like write the same code but in C. Like, because that should work, but it doesn't make any sense. So, yeah, well, let's go ahead and port it to C, because like maybe I'm like very stupid and cannot see like obvious thing. Right. So I'm gonna just literally rewrite that in C in here. I might as well just, though it's kind of, you know, painful to read files. Look, I don't have such a convenient function that reads everything in C in here. Will it be possible that you read a blank line from a sample txt? It's quite unlikely. It is quite unlikely, but maybe. To be fair, okay, so maybe I should not rely on str2i64, right? Maybe this is something that I shouldn't do. Let me go to my previous solution and just copy-paste parse word, right? So what if we just like, yeah, what if we just like go until the new line? I can probably implement that myself. And basically, do that on the level of characters. So let me try to run it one more time. This doesn't look incorrect, right? So this is 4. The first one is 4, right? And that makes sense. This is 4. That is true. And then we have something like 30, which is... Why is this 30? Is this 30? This is 30, okay. Nothing here looks sus, to be fair. Everything looks okay. Everything looks fine. So, and then in X... You have to initialize epsilon with 1111111. But why? I don't think I have to. I don't think I actually have to, so it should be fine. Oh boy, so maybe I should make a small break. So let me actually, you know, make a small break, you know, get some fresh air, maybe get some tea, and I'll try to think about it more. Like at least think about the ways I can confirm that it's not a bug in a Holy C compiler or something like that. So yeah, because it's really weird. Anyway, small break. All right, so let's go ahead and rewrite it in pure C, because like I have no idea. Seriously, it should work. It works in my head, and I don't understand why it doesn't work here. Like seriously. Somebody suggested a cool thing. Memset instead of... Oh, shit! Whoever said that? Madmix. Madmix, you're getting VIP. Holy fucking shit. So... so dumb. Thank you so much. Okay, so as you can see, I don't have a divine intellect. I have actually pretty small brain. What can I say? So, and it's 190. Yeah, so it's precisely that. Thank you so much, F1234KY, for gifting sub to Madmix. Thank you. All right, we figured it out finally. Holy shit. Yeah. So because I went off of the assumption that everything is initialized correctly, and I was trying to find an error here, but obviously there's no error in here. There's error here in a place where I would never actually assume that, right? So it's always the case, right? You would never assume the error somewhere here. Anyway, so we want to increase the amount of bits, because now in the actual sample we have 12 bits, and I'm gonna go into the input, right? So I'm gonna do the input, and I suppose the part 1 is this one, right? So I might as well, so here are all of the numbers. I'm gonna print some stuff. What the fuck is going on? Okay, so I want to remove some of these things, right? So these things are not particularly useful. We don't need count, right? We don't need count, and so we probably don't need that stuff as well, right? So gamma d epsilon d. Tooth, thank you so much for tier 1 subscription. Thank you.
Is there Holy Haskell, or is it already a religion?
Is there Holy Haskell, or is it already a religion? I mean, Haskell is already a religion by itself. It doesn't need to be holy. Alright, so here's the epsilon. I want to just double check everything and make sure that everything's fine. And let's do that. Okay, 2, 5, 9, 58, 24. Hopefully, I didn't do any significant fucky-wacky yet again. 259, 259, 58, 24, 259, 58, 24, 259, 58, 24, and submit. And thank you so much. Isso, kawaii freaking desu. Okay, so god damn it. Okay, let's go to the part 2. Okay, next you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Holy shit. Both the oxygen generator rating and the CO2 scrubber rating, I'm not even sure if I pronounced that correctly, are values that can be found in your diagnostic report. Finding them is the tricky part, tricky dicky part. Both values are located using a similar process that involves filtering out values until only one remains. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then, keep only numbers selected by the bit criteria for the type of rating value for which you are searching. Keep only numbers selected by the bit criteria for the type of rating values for which you are searching, discarding numbers which do not match the bit criteria. What is the bit criteria? If you only have one number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process considering the next bit to the right. Holy shit, this is gonna be fun. The bit criteria depends on which type of rating value you want to find. Okay, cool. So it's like, it's intentionally overcomplicated. The description is intentionally overcomplicated. It's artificial difficulty. I hate artificial difficulty. Right, it's just like you run out of ideas, and how can you make the problem more difficult? You just add more indirections in the description, of course. The bit criteria depends on which type of rating value you want to find. To find oxygen generator rating, determine the most common value, 0, 1 in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 1 in the position being considered. To find determine the least common value, 0, 1 in the current bit position, and keep only numbers with that bit position. For example, determine the oxygen generator rating using the same diagnostic. Report the above stat with all 12 numbers and consider, well, I don't care. And demand scriber. Finally, to find the life supporting rating, multiply the oxygen generator. Ran out of ideas on day 2. It's already day 3, right? So it's actually day 3. It's just like, it's not even hard. It's just like uncreative. Like, it's uncreative difficulty. It's like, it's freaking embarrassing. Okay, anyway. So the one thing that I didn't actually understand is probably this part. Both values are allocated using similar process. Before searching, keep only the numbers selected by the bit criteria for the type of rating which you're searching. Discard numbers. Okay. If only one number is left, do for that. Okay. Okay, to bit criteria depends on which of the type rating. To find oxygen, determine the most common value in the current bit position. So they're talking about current bit position, and I'm not sure if I understand what's the current bit position. Current bit position. So the current bit position was only mentioned for the first time in the bit criteria and was never actually explained before. So I think maybe just bit position, yeah, it's for the first time was introduced in here, and this is where it doesn't make much sense. The common value in the current bit position, and keep only numbers with that. If 0, consider that. Okay. So I suppose to understand this thing, I need to read the tracing of the algorithm for the sample. Start with all 12 numbers and consider only the first bit of each number. Okay, there are more 1 bits, 0 bits, okay, in the first position. Then consider the second bit of the 7 remaining. Okay, so basically you have a notion of the current bit position, which is initially 0, and on each filtration you increment it by 1, and nowhere here it was actually explained explicitly. You only can derive that by reading that trace log of the algorithm, right? So, okay, makes sense, I suppose. Consider the third position. In the fifth position there is that, and there is that, blah blah blah. To remind the all right, right. Am I dropping frames? I'm not dropping frames. You're dropping frames. I'm eating apples. Okay. I guess it's pretty straightforward, isn't it? So we probably want to store. We probably want to store this stuff. Oh, and we'll have to recalculate the bits thingy over and over again every time we filtrate or not. So yeah, that's one of the things we'll have to do all the time. So, and we need an array where we're gonna store the numbers, right? It would be nice to actually store them somewhere. And I also need an array that indicates that we got rid of the number, right? So we got rid of the number. So some sort of like a Boolean indicator that this number is out. So then when we do the bit calculation, we don't have to do that. Okay, so let's go. I'm gonna create part 2. So this is going to be part 2, and it's going to be U0, right? So this is U0. 2. So maybe we, so I probably can do like a malloc, but I don't think it's a good idea. So let me do something like access capacity. So this is going to be access capacity. And let's say, it depends on how many numbers are going to have in there. So let me take a look at the input. All right, so, oh boy. So here is that. I'm gonna copy paste this entire thing in here. And I have thousands of them, which is all right. So I can say that the capacity of this entire thing is gonna be 1024, right? So this is gonna be I64 access capacity, right? And then we're also going to keep track of how many things we have in there. It's going to be access size, and initially it's going to be 0. So we're basically going to append that into that buffer. Right, so do we have a boolean of some sort? So there is a boolean, right? Access removed or something like that. So it's going to be access cap. And that is pretty much it, right? That is pretty much it. So as we read everything, we're gonna fill this thing out, and okay. So I probably need to copy paste this entire solution, right, and adapt it to like reading the whole thing. So I'm also gonna put this in here. So we're reading the samples, right? So initially reading the samples. So it would be probably nice to have some operations, something like U0 read access, right? And in here, I'm gonna actually put all of that stuff in there. So, 2. Oh, this is a very tight editor, so it gives you like a tight feeling, if that makes any sense. Okay, so we don't need to do that. All right, so we're reading just X, and in here we're gonna simply do the following thing. So it's gonna be access size is gonna be equal to X, right, and then access removed access size is going to be equal to false, and I think it has to be maybe something like false. Okay, so there is a boolean, but is there some, maybe it's false. It's false. Okay, so I presume that since this thing is highlighted, it's the boolean type, and since this thing is highlighted, it's like the value of that boolean type. All right, so this is basically the assumptions that I make. I'm not sure how, you know, safe it is to make such assumptions in such an operating system, but it is what it is. All right, so we basically read everything, and now we have the access. All right, so let me see. 2. I'm gonna read access. And maybe I'm gonna actually print something like read D values, right? So we read this amount of values, and we're gonna do something like access size. And here I'm gonna actually call part 2, and I'm gonna just run this entire thing, and it didn't even compile. It failed on the line 50, right? So let's actually go to the line 50. So in the line 50, size T. Yikes. Reflexes, by the way. So there's no size T. Okay, so unused variable I. Oh, it even complains about the warnings and stuff like that. So it says read 0 values, which is actually a good indicator that I did a fucky-wacky. So I need to do something like access size ++, right? So, and I read 12 values, okay, which is actually correct. So maybe I'm gonna actually remove the values that I don't use. Thank you so much for telling me that. I really appreciate that. Okay, so this is a 12 values. Some Wadu, thank you so much for...
Always providing great content, thank you, Tsuding.
You're welcome. Thank you for 4 months of tier 1 subscription. Thank you, thank you, thank you. Really appreciate it. Welcome to our epic TempleOS club. So let's take a look at the input, and in the input we actually read 1,000 values. Okay, so that's fine. Cool. I could have actually like dynamically allocate this stuff, but is there something like reallocate in TempleOS? Right, realloc. Oh, there is no such thing as a realloc, right? A realloc. So there is a malloc, but it's actually spelled really weirdly, right? And maybe m realloc. I don't know. So maybe there is no such thing as a realloc, but it is what it is, and it isn't what it isn't. So we read access. So we read this amount of values, and now what we need to do. All right, we need to have an operation that essentially computes the bits for the current unremoved access, right? So we already have the buffer for the bits, so that's fine. We can reuse that. So let's create an operation called bits of access, right? And essentially what it does, it iterates through all of the access that are not removed, right? And computes the common bits for all of them. But do we have to do it? Right, so I didn't think, no, we don't have to do that, because we only have to do that for the current bit. Right, we only have to do that for the current bit. Okay, so but we still can have like a common operation for that. So essentially, I can provide the bit, right? So I64 bit number, right? For which bit we're computing all of that, and then I can return 2 values. I need to be able to return 2 values. Unfortunately, Holy C does not allow to return several values, I think. Does it allow to do that? I think it doesn't allow to do that. Right, so we'll have to do it like this. I64 ones and I64 zeros, right? So there we go. And that way we're going to iterate through all of the unremoved ones and compute everything accordingly. Though, again, I could actually do the same trick, because why not? I can try to do the same trick where I would just accept the bits. Can I accept something like this? I think I should be able to. Okay, so let me try to compile the program and see if this is syntactically correct, more or less. No arrays in function args. Oh, he even explicitly tell us no arrays in function args. Okay, so does he mean that arrays are not allowed in function args or something like that? I'm not sure what he means by that. Yeah, apparently you can't do that. So that's fine, I guess. We can just remove it like that. It's kind of interesting. Right. So that is, yeah, maybe to avoid confusion, like in pure C, where the arrays degrade into like pointers and stuff like that, right? So he basically just forbid passing, you know, arrays as arguments or something like that. So anyway, so let's iterate through this entire stuff. So we're gonna have something like I equals 0, I less than access size plus plus I, and in here we're only gonna consider those that are not removed, right? So if access removed, actually I, if this thing is not removed, right, we are doing what? We are taking the value, right? So access I, and we need to know its bit number, so we have to shift it by bit number, right, bit number, and then we have to take the bit out of it. So I think this thing should be called bits, right? Bits, bits, and then we're gonna simply do it like that. So it's gonna be plus plus. So this is basically the entire operation. This is basically the entire operation. Alright, so let me see if it compiles. Undefined identifier at 74. 74. Where? Oh, okay, so because I never actually declared this thing i64i. So, and everything seems to be okay. So we have bits of access. Cool. So now, after we read all of the access, we want to start the process. Here's an interesting thing. We also need to know how many access is already left. Right, so there is access size, right, like how much of the memory we consumed in here. And we also want to have something like access CNT, right? So how many access is left? Right, so this is going to be something like access CNT initially is equal to access size, but as you remove more and more things, right, as we remove more and more things, we're gonna get rid of that. So another interesting thing in here, I think I also need to clean up the whole stuff, right? So I need to clean up access, I need to clean up some other stuff, right? I think it's quite important. Access z is equal to 0. Then mem set, can I mem set boolean, right? So I probably have to. I wonder what is boolean itself, right? Is it 64 and what's the size of the boolean and stuff like that? Is that a good idea to use boolean? I'm not quite sure, but I can just use a regular mem set for this entire thing. Can I do size of? I feel like I can do size of. Okay, so mem set i64. The destination here is going to be access. The value is 0, and the thing I'm going to put in here is access cap, right? So for that one, I'm going to do mem set access removed 0, access cap, but multiplied by size of boolean, right? Size of boolean. So we cleaned up everything, and we also probably want to do access count, but access count is going to be rewritten by sizes, so but just in case I'm going to put 0 in here. Alright, so everything seems to be compiling. Everything seems to be compiling, and okay, so every time I sort of reread everything, I'm going to clean everything up. Alright, I think we are ready to start the process. So for different things, we're actually removing different stuff. Oh my god, what the hell is going on? For different things, we're removing different stuff. Keep selecting bit criteria. If you on the left side, this is rating value for you searching for. Okay, that's cool. That is very, very cool. Alright, so while access CNT is greater than 1, right, while it is greater than 1, we're gonna keep repeating the same process, right? I'm gonna keep repeating the same process, and we need to keep track of the current bit, right? So we need to allocate that current bit somewhere. i64, so it's already called bit number, so let's actually call it 0. But it has to go from the other way, right? So start with the 12th number and consider only the first bit. So we have to actually go from the from that one. So we can actually quite easily do something like this. So it's going to be bits count minus 1, right? So yeah. And as we go further and further, we decrement the bit number, right? So in this case, we have to go in a different direction. Okay, so cool. What I'm doing is I'm going to be allocating i64 bits. It's going to be 2 of them. All right, and I just do bits of access. I provide bit number, the current bit number, and then the bits. And I wonder if this entire thing is going to compile. It still compiles. Okay, that's cool. So the arrays, they degrade into the pointer, but you can't basically put arrays into the signature, which is kind of cool, right? So it kind of prevents the confusion. You still can basically put array in a place where you expect a pointer, but you cannot put array in here, confusing the users of your functions. You see what I'm talking about? Right. So I think it's maybe a good decision, right? For, I mean, I don't know. We'll see. Okay, so what we're searching for? We're searching for the oxygen, right? So there are more bits for 7 than 0 bits, so keep only the... okay, so let's actually allocate the oxygen variable that will keep track of the oxygen. It's going to be I64, oxygen initially 0, right? So this is a bit number, and so we need to remove the things that have more ones. The moments, so keep only the value 7 with the ones. So in here I'll have to start iterating all of the axes, right? So I have to start doing 0 less than axis size, and I only have to consider the things that are not removed, right? So let me actually go somewhere here. We need to consider only the things that are not removed. If axis is not removed, right? If axis is not removed, this is the thing that we actually care about, right? So this is this thing that we actually care about. So axis I, and we wanna access it's like the current bit, right? So it's gonna be bit number, right? So this is the bit number. This is a bit number, and we do 1, right? So this is the value. So I can probably maybe save it to the bit, right? So this is our current bit, so it's a little bit easier to reason about this entire thing. I64 bit, and here is an interesting thing, right? If the amount of ones is bigger than zeros and bit is 1, we have to leave that value. So this is where it gets a little bit confusing, right? So to find oxygen, determine the most common value, 0 or 1 in the current, and keep only numbers with that bit in that position. Okay, so if the common value is 1, right? So bits 1 is greater than bits 0 and bit is equal to 0, that means we have to remove the current value, right? I wonder if there is a good way to, you know, just compress that into a single solution, right? I think there should be. Right, I think there should be. If 1 is more common and bit is equal to 1. Okay, so we can try to do something like this. Right, 1 is more common, so we can probably want to do it like this. And bit not equal to 1, so we have to remove it. 0 is more common, right? 0 is more common, and bit is 1. So, okay, so that actually makes sense. I think this is actually a pretty cool idea. So if this is the case, we have to remove this entire thing, right? We have to remove the value out, right? So this is going to be access removed I equal false, and we also have to decrement the access count, right? So it's CNT minus minus. There we go. Right, and we have to do that up until like access is greater than 1. Right, and then we found the value, I suppose, right? We found the value. Let's go ahead and try to do that. So we're gonna do something like access count is gonna be D, and access CNT, right? So I'm going to try to compile the entire thing. It does not compile because we have undefined identifier. So for I suppose we need to define it somewhere here. So it's going to be I64I. So I should not put this thing in here. And there we go. Invalid L value at 103. Okay, so let's actually go 103. And what do we have in here? Invalid L value. Oh, this is because, okay. Oh, it's actually, it has to be on the other way around. Right, so because it's a boolean or something, I'm not sure. Unused variable oxygen. Oh, okay, so I was actually right. So that's fine. That is fine. Okay, that is a little bit scary. I don't know if it's gonna work because it's a pretty complex thing, and if it's gonna break, I don't know what's gonna happen. Okay, access count is negative. It became completely negative for whatever freaking reason. So, which is kind of strange because why would it become negative? The fuck? Alright, so let's actually print it before in here. D.
I wish I could understand any of this coding.
Thank you, Set Primate, for 2 months of Twitch Prime subscription, tier 1 subscription. Thank you, thank you, thank you. Okay, so let me see. So initially it's 1000. We're trying to do that on the actual input. I don't think it's a good idea. So we have to go to read access, right? Sometimes it's just easier to just click on the mouse because there's no good efficient way of... Okay, so we hogged the whole operating system. Okay, so we only can kill it now. All right. So I wonder what exactly went wrong. So let me see. It's gonna be no. I'm gonna remove that, and we're almost done. So this is gonna be dir and AoC 03, 03 and main.hs. Okay. So what is going on? So it feels like it never actually. Yikes. Okay, so if I try to do just return, right, so in here, it's going to be fine. Okay, that is totally fine. Then here, there's something weird. We can try to maybe print the actual count and see where it goes, right? Access CNT D, it's gonna be access CNT, right? So, and it's always like 12. So it's never decrementing, so it was never the case. So it could be that maybe bits of access never really worked out. Oh, I think I know what the fuck is going on. We never actually clean up bits. Okay, so maybe this is something that we want to do. So I'm gonna do mem set I64 destination 0, and we want to do 2 of them. So if I do that, okay, so it never, it still doesn't work, which is kind of sus, not gonna lie, right? It is kind of sus. So this thing... So it's not removed. So we do all of the bits. Then if it's not removed... False! It has to be true. Because, yeah, so we have to put true in here. And still doesn't work? Okay. So initially it's going to be false. Interestingly enough, we don't have to memset this entire thing. Yeah, we never actually have to memset any of this. Except SZ. Right, because we override all of that, so it doesn't really matter in here. Right, so... Still is never actually removed. Okay, so... Bit number... And it's 1. So what am I missing yet again? And the font is so unreadable. Like I cannot focus on a single statement because of this font. It's so hard. It's so hard to focus on reading this thing. It's just like, oh my god. Okay. So let me see. But maybe I'm slowly getting used to that. Bits of access. Oh, I also have to increment the bit. I forgot. Yeah, I forgot that you have to increment the bit afterwards. Right. So then next bit and then next bit. Okay. So then we have to do not really increment bit, but bit number like minus, right? So that's what we have to do. And is it gonna finally? Holy shit! So. Okay. So interestingly, like for a couple of iterations, it's stayed on 12, which is bizarre to me, which is not like a thing, because this is definitely not correct, right? So this is definitely not correct, but then it's sort of settled on axis. So why would it, like, it's really, really sus. Because already at this point on the first iteration, it should remove a bunch of things, right? So, but it didn't. It actually didn't. So there's something really sassy going on. Right. It is definitely something sassy. So bit number, bits, we clean up everything in here. And yesu. Kawaii freaking desu. So let me see why there's several of them. My god, what am I missing? But the next thing, regardless of anything, right? Regardless of anything, we can just iterate through the entire thing and find the one that is not removed, and that could be the one that we're looking for, right? So less than access as z plus I, right? And if access I, access not removed, right? So this is not removed. It is not removed. We're going to just print the value of it, right? So the value is essentially access I, and I wonder if that's the correct one. After that, we can just basically return out of the procedure, right? So, and it was 22. Was it 22? So it was actually 23, so it was not correct, I think. Right, so it was definitely not correct. But it found 22, for whatever freaking reason. Okay, so we're moving in the right direction, more or less, moving in the right direction. So, but I think I want to make a small break, and then after the break I want to continue and see what the hell is going on. Right. So, all right. So I think I potentially realized what the fuck is going on, and I'm using sample, but the bit count is 12, right? So I forgot that between the sample and the input, we have a different bit count, and we have to keep track of that. So I have an idea, actually. Let's do the following thing. Right, so let's actually have two constants in here. This is going to be input file, right? So, and this is going to essentially be input txt, right? And maybe somewhere here I'm going to keep something like if 0 is going to be one thing, and otherwise it's going to be a different set of these things. And so I can quite easily basically switch between the sample and the input. Right, so and in here we have 5 bits and the sample, right? But that will require me jumping here, but this is like a third line, so it should be relatively straightforward. So for the part 1, I'm gonna just set, so I'm gonna just select this. I cannot even select this entire thing, I have to do that manually. I don't know what the fuck just happened, but oh, okay, so I have to press Ctrl X. So input file, right, so this is the input file, and then I go here, and this is another thing. So then input file. Okay, cool. So this is input file, and then it should be really easy for me to just switch between those things. So now this is 0, right? So it's gonna use the sample input and not the input. So I wonder if Terry allows to do something like this, but I'm not gonna risk it for the biscuit. So let me see. Okay, so I'm gonna try to run this entire thing, and it is working, right? Right, it is working, and here we have a reasonable amount of things, right? It does look like a reasonable amount of things, but the actual value in here is not 23, and it's supposed to be 23. Elkan, thank you so much for Twitch Prime subscription. Thank you, thank you, thank you. Really appreciate that. So, right. So here we have, so keep only 7 numbers, right? Then we keep only 4 numbers, and then set position 3. So it actually degrades like really reasonably. 7, 4, 3, 2, 1. Right, 7, 4, 3, 2, 1. So the only number that stopped is the correction is 23 in decimal. Right, but this is not true. This is not true, and this is really, really strange. Really, really strange. So one of the things I want to do actually is maybe just do something like this. So this is going to be D and D, right? Access I and access removed. And let me just get rid of that. So this is very interesting. So here is a 23 and here is a 24 or 22, I mean. All right, which is kind of sus. So they're nearby, but at the same time it's kind of like, maybe I made a mistake somewhere here as well. Let me see. So we read access, then bits of access. It cleans up the bits, right? It cleans up the bits. We iterate through the entire thing. We don't care about the removed, right? If this entire thing is not removed, I shift that specific bit number, right? And then add 1 and I increment it by 1. Okay, that's cool. So I do that once. Then I iterate this one more time. If this thing is not removed, I get the current bit number, right? So I extract that bit number. And if the common bit is 1, so command bit is 1, the entire thing is going to be true. Though we can do something like this actually. We can say equal 1, right? We can say equal 1 and it's still 22. Thank you so much, CNJ Dog, for Twitch Prime subscription. Thank you, thank you, thank you. Welcome. Okay, so this one is rather interesting. Don't quite understand. I wish there was like an easy way for me to also print the bits counts, the bit counts or something. Thank you so much, Trouser Down, for tier 1 subscription. Thank you, I really appreciate it. So let me read it one more time. Consider only the first bit of each number. There are more 1. So keep only 7 numbers with 1 in the first position, right? So did I mem set something incorrectly again? I didn't think so. I didn't think I mem set anything incorrectly anywhere. I don't see the problem. I don't see the problem yet again. Okay, so we can do something like that. So bit 1 is greater than bit 0 and bit equal 1, so it's going to be true. And if they're not equal, we remove that. So if it's going to be false, and this thing is going to be false, they're going to be equal. So this is going to be false, so they're not going to be removed. So it feels like I made a mistake somewhere here, but again, I'm not 100% sure. I may try to do like a first single iteration or something. So let me have an operation that dumps the current state of access, right? Something like dump access, right? And essentially what I want from this entire thing is iterate through all of these things, access size plus I, Right, so access eyes. And I want to print the number in bits, right? So to do that, I'll have to do something like so I need actually J in here, I64, IJ. Right, so the J is going to be equal to bits count -1, J greater or equal than 0, right, and then -J. Cool. And here I should be able to do the following thing where can I do like C, right, and then I do access I, then Shift J, take 1, and then I want to actually add a character, something like +0, and it will turn it into 0 or 1, right? It will turn it into 0 or 1, and it's going to do that for a while, right? Then I'm going to add this thing, and I'm going to also say access removed. That way, we're going to sort of like dump the current state of the access after removal and whatnot. So we read the access, right? So we read the access, dump access, and then I'm going to just return just to see the current state of this entire stuff. Okay, there we go. So here are all of the things. None of them are removed, right? So that's kind of the point. Right, so that's kind of the point. Then what I'm going to do, after the first iteration, right? So after the first iteration, I'm gonna just remove this entire thing, right? This is like operating system is really annoying. Okay, so this is the first iteration, and dump access, right? Dump access, and I'm gonna just return right away just to see what got removed. And okay, so we have unused variable, but apart from that, file not found. Are you serious? Why would you fail with our file thing? What? Why would you fail in such a weird place? Where did it go? Okay, so it could be that I accidentally removed CD. Okay, I accidentally removed CD. Okay, so let me take a look. C, and it's gonna be home AoC. 2021 and it's going to be 03, right? So this is going to be something like this. Hopefully now it will work. None of them were removed after the first round, which is kind of sad. Or this is because I forgot to remove this thing, right? So these are the things that were essentially removed, right? So 0, 0, 0, 0, because none of them have the, you know, the most common one, which is 1, right? So, and all of them got removed, right? So that's pretty straightforward. Okay, so maybe while dumping this entire stuff, maybe I should not even consider removed, right? So basically, just always show what are the things that are left, right? So, and if access not removed, only then. Just do it like that. It's so painful to use this text editor. Holy shit. Ooh. And you cannot just like indent anything, right? You have to do that manually. Holy fuck. Okay, so these are the things that are left, right? So they are the only things that are left, and I want to compare them with the things that are actually left in there, right? So 1110, 1001, and I'm going to take a look at the last one, and everything seems to be okay, right? Everything seems to be okay. So let me maybe read a little bit more careful. Then consider the second bit of the 7 remaining numbers. There are more 0 bits 4 than 1. So keep only 4. So there's something with the 0, right? So we want to actually stop after the second iteration now, right? We want to stop after the second iteration, but that means we have to keep track of the iterations, right? But maybe we already keep track of the iterations with the bit number, right? So the bit, well, the bit number is really unknown. Okay, so let's actually have something like a J. We already, no, we don't have that. So this is going to be J. And in here, I'm going to do a J plus 1. All right, so on the second iteration, right, if, so this is going to be 1, and then it's going to iterate to 2. If J is greater or equal than 2, right, then dump and return. So I'm going to actually try to do it like that to see if it's what I expect, and then 2. So this is what we got on the next iteration, right? So this is what we've got on the next iteration. Okay, then consider the second bit. Okay, so keep only the 4 numbers with the 0 in the second. Okay, so here are the 4, and we can clearly see. So we're basically like tracing the whole process, right? So we're tracing the whole process. Okay. In the fourth position, 2 of the 3 numbers have 1, so keep only. Okay, in the third position, 3 of the 4 have this. Okay, so let's actually go here. So this is going to be 3, and this is they are. Here they are. So 1 0 1 1 0, 1 0 1 1 0, 1 0 1 1 1, and 1 0. So far so good. So far so good. Right. In the fourth position, fourth position. In the fourth position, only 3. Okay, so let's go to the next one. So this is going to be 4. Okay, that is. So this is the fourth position. In the fifth position, there are an equal number of 0 and bits. So to find the oxygen, keep the number with 1 in that position. Oh yeah, I never considered the situation when they're equal. Right, I never thought about that. Yeah, okay, so all right, so that makes sense. Okay. So oxygen, to find oxygen generator rating, determine the most common value in the current position. If 0, I missed this sentence. Holy shit. Okay. Why are you highlighting this thing and don't highlight this thing? I think this thing is more important. Okay, come on, keep values with 1 in the position being considered. Okay, cool. I see. So that means here we actually have to do something like 1. Right, so, and because of that, I should be able to just do that. I'm gonna keep around dump access because I think it's a pretty useful way to debug this entire stuff, right? So there we go, and we have 23. Finally, we have 23. That's pretty cool. All right, we did it, Reddit. So let me see. So let me remove this entire stuff. And I suppose. Yeah, so I'm gonna just go ahead and do like this, access removed. If this thing is not removed, I'm gonna remove it. I'm gonna return it from this thing. So, which is rather interesting. Maybe I need to rename this operation to something like to oxygen, right? So we can do something like this. It's gonna be I64. and this is going to be the oxygen. Right, and we don't really need this operation anymore, but that also means that we need to come up with a new main, right? So this is going to be the new main. So U0 part 2. So here, what I'm doing is I'm reading access, right? So I don't have to read access in here anymore. And I suppose before computing the oxygen, we need to clean up the removed, right? So I need to do mem set access removed, and I'm going to set them to 0. And it's going to be access cap multiplied by size of boolean, right? So this is going to be size of boolean, and access count is going to be back at access size, right? So this is going to be access size. Right, and the only difference, by the way, between oxygen and the second weird thingy, right? So I don't even know what it is, CO2, is that I suppose this condition, right? So it's rather not equals or equals. And I'm not sure how to customize this entire thing. So we can do something like this. So how is that process even called? To Scrubber, consider just the first bit before searching. Okay, so we can do something like search value. Search value, right? So this is a search value, and we're gonna have a Boolean flag that indicates like how to treat this entire thing. So we've got a subscriber. Just a second. Thank you so much, Mr. Piano 12. Thank you, and welcome to our epic TempleOS club. All right, so yeah, because I want to use like the same code for both Oxygen and COS scraper, whatever the fuck it is. I don't know what that word means. I'm sorry, I don't speak English. What is that scraper? Macmillan. Translate google.com. So good evening to you too. So we're gonna translate to Polish. I don't speak Polish, but anyway. A brush or other object used to clean something. CO2 brush. Oh, it's like a scrub. Okay, so CO2 scrubber is like a thing that gets rid of CO2 when you exhale it. Exhale it. Right, so that's probably what it is. I don't know. It probably doesn't matter, right? So, so let me see. So this is going to be something like Boolean. So it's a common, and this is going to be true. All right, and essentially, if common, right, we're going to do that thing. I wish there was like auto indentation. I wish there was an auto indentation, but it is what it is. Otherwise, we're gonna do it like that. At least I can select like lines and copy paste them. Something like this is the easiest way to actually do that. Okay, here we have part 2. We read the values, then we're gonna have I64 oxygen, oxygen equal to search value, right? And then we're gonna have I64 CO2, which is gonna be search value false, right? Search value false, and there we go. We have oxygen and CO2. So we can actually print them. Oxygen D, oxygen, and then CO2. Let's actually align everything so it looks a little bit prettier. And there we go. So I'm going to do part 2. Boom. And okay, oxygen 23, CO2 is 10. And is that the case? It is in fact the case. Would you look at that? Would you look at that? Isn't that POG? Fellow kids, I think it is. So we're gonna do something like part 2, it's gonna be D, and we're gonna simply multiply oxygen by CO2 in here. There we go. So this is to 230. 230. Okay, so that took a while, right? So, but we managed to do that anyway. Because that's what you do in a Guts temple. You take your time to implement the solution. All right, so now we're going to be switching to the input, and there we go. So apparently the solution is going to be 213, 52, 53, and that is kind of sus. Isn't that the same as part 1? Am I going crazy? Wait a second. So if I enable part 1 as well. No, it's actually different. They kind of look similar, but they're actually different. Okay, so let's go ahead and submit that. 213, 52, 54, and the moment of truth. Did we... Okay, we won. We won, Zulu. How about that? How about that? Yo! And it took exactly 2 hours. It took exactly 2 hours stream. So yeah, we managed to do that. We did it, Reddit. We actually freaking did it. That was hard, but I managed to do that. Wasn't that poke? I think that was poke. Okay, so let's do a committee and maybe then even pushy. All right, so that's cool. I really like this approach where I could just like switch between sample and input and stuff like that. But anyway, so the way you essentially commit the solutions, right? So you do synchronization and you synchronize into the host, right? So what it will do, it will mount everything, right? And then it will copy the solution out of the temple into the host. So if you take a look at your Git status now, here is this the solution. I can add AoC, right, and then div cached. And here is the solution that we wrote in the TempleOS. And I can just go ahead and do commit add solution for day 303. And then I'm going to push that right into the repo. Git push origin master. Right. So, and again, you can find the solutions here in the repo. I'm gonna copy paste it in the chat, and for people who watch on YouTube, you can find this entire thing in the description, of course. So I'm gonna refresh this entire thing. All right, and the solution for the third day is already available. Right. Okay. So that was pretty poke, wasn't it? I think it was pretty poke. I think I'm slowly getting used to the editor and TempleOS in general. Still make a lot of mistakes, and the font, it is really hard to read the font. Like it's just like I'm trying to focus on something and just like I cannot focus by looking at that font. It's just like so horrible. But yeah, maybe eventually my brain will make sense out of all of that. So yeah, we'll see how it goes. And I'm trying to click in here, but it doesn't work. So here's the AoC 03, and this is the solution. Maybe there is a way to change font and color theme. Maybe. So there is a way to change colors, that's for sure. But I'm not sure about the font. Font, it feels like font is like a very much hard-coded thing into the whole operating system. So I'm not sure if it's that easy to change. The only thing I would change about the current font is I would add a little bit of spacing between the lines because they're too close together. Maybe you can add a little bit of spacing by actually making the font a little bit shorter, right? So, and that will effectively space apart those things. It will make it smaller, but at least they're going to be spaced apart. If you know what I'm talking about. Specifically letters, because it's not going to work for the lines in here. I presume the lines also part of the font, maybe. I don't know. Maybe you can edit character font sprites. This is exactly what I'm talking about. So basically make them shorter or something like that. But they're already like very compact, right? So I don't think you can easily make them shorter. So yeah. All right, I guess that's it for today. Thanks everyone who watching me right now. I really appreciate that. Thank you for all of the subscriptions, for all of the support. I especially appreciate that. And I gotta go. Thanks everyone for watching. I need to ungrab my mouse. And I see you all next time. Love you all.